This is a guided walkthrough for the simple challenge from HackMyVM.eu, and let's begin the challenge. So simple is a Windows machine, and we're going to learn how we do enumeration against Windows machines, how to locate them on your network, and how to scan them. Okay. So to locate the machine on our network, what we need to do is we need to use Nmap, and we need to give it a IP range. So in this case, to figure out what our IP address is and what our IP range is. So the network we're on is this one over here. So we're just going to scan this IP range, and we're going to figure out where the machine is that we want to hack against. Okay, so I'm pretty sure the machine that we want to look at is this one over here at 117. I think our machine is located at 116 over here. And for some reason I'm not exactly sure why we have two IP addresses, but it looked like we had two IP addresses over here. No prefix route on dynamic, and there's a secondary one as well. I think we can use this one for our IP address. Anyways, okay, let's do our Nmap scan. So we're going to do our Nmap scan against the target. The target is going to be located at 117. We're going to give these arguments over here. Be threads, and it's going to be very verbose. And we're going to get information as well as common scripts against whatever services we find with these arguments over here. So after that, we're going to run the Nmap scan, and we're going to get immediate results because we gave this very verbose flag over here. If we don't do this, we will not receive any output from the program until it finishes scanning. So over here, we've identified a number of openings on this Windows machine. So port 139, port 135, and port 445 are all very commonly open ports on Windows servers. So 139 and 445 are both associated with the SMB service, and 135 I think is associated with the NetBIOS service. But anyways, now that we know that there is indeed SMB, this service on the Windows box, we can start doing some enumeration against that. What we can also do is enumeration against port 80 over here, which commonly has the HTTP service running. So let's go ahead and take a look at the web page and see what's going on over there, over on 80. So this is the IP address. So let's copy that, and then let's go over to our web browser. So we're in our web browser. Let's go ahead and navigate to that page. Okay. So it says here, coming soon. I'm not sure what language this is. Maybe it's just a typo. Okay, but what else we see on the website is that there's a number of usernames over here. It says, thanks to the work team, Free, Marcos, Lander, Bogo, and Viper. So with this information, what we can do is we can start piling a little list of users on this target. So we're going to copy this this list of names, and then we're going to go over to another tab, and we're going to create a little users list. So we're just going to use nano, and we're going to create a file called users.txt. So inside of nano here, I'm going to format this so that we can use it as a usernames list, just like this. And then we're going to save the file. Okay. So now that we have the file saved, we can actually do some enumeration with the Netexec program. So the Netexec program is basically a very, very powerful tool for enumerating Windows servers. So Netexec is a program that can be used to enumerate all sorts of things on Windows servers. You can use the netexec command, or you can just abbreviate it to NXC. And what we're going to do, what we're going to do here is we're going to scan against this IP address here, and we're going to scan against the SMB protocol. And we're going to try to log in to the SMB service with every name on the users.txt list. And as the password list, we're going to also use the users.txt list. What this does is that it uses, it's basically going to use the username as the password. So we had, or what would we have? So we would use username Rui and password Rui, username Marcos and user Marcos, username Lander and password Lander, etc., etc. You'll find that sometimes usernames use their username as a password, and this is the type of vulnerability we're trying to exploit here. So along with this command here, we're going to specify that this is not a brute force attack. We're only going to try one password per user, and we're also going to continue on success, which means that if we find a successful username and password combination, we're just going to keep on going. So with Netexec, we're going to scan the SMB service on this IP address, and we're going to try to figure out if any of the users have used their username as their password. So let's run the command. And we found that most of these came back unsuccessful, except for this one. So on this server, the simple server, the username BOGO and the password BOGO these two are valid credentials. So what we can do next is we figure out what access BOGO has. So we're going to do the same thing. Well, we're not going to do the same thing, but we're going to continue to use Netexec. But this time we have a valid username and password. So it's going to be username BOGO, password BOGO. And this time we're going to use Netexec to figure out what shares are available to this user. So the SMB service is a file sharing service, which means that if a user has a user account, they might have access to certain file shares. So this command is going to let us know what file shares BOGO has. Okay, so over here, this is the file share information. So BOGO has read access to the IPCS share. This is for printers, I'm pretty sure, but they also have access to the logs share over here. They've got read access. There's also a web share, but we don't have access to that as the BOGO user. So what we can do from here is we can try to look into the logs file share and figure out what files are in there. So we're going to use a separate program to access the log share. What we're going to do is we're going to use this program right here. It's going to be BOGO. So SMB client, as the user BOGO, we're going to try to access this IP address and this file share right here, logs. So we're going to run the command. It's going to ask for the password. So the password for BOGO is BOGO, conveniently enough. And now we're in SMB. So now that we're in the SMB service, we can use dir to get all the files in here. And we see that there's only one file in here. This is this, I think this is a date. So this is 2023, September, maybe, September 8th. That's what I'm going to guess. So this is some sort of log file, and we have access to this. We can probably download it. So to download this file, we would use this command. It's going to be get and then the name of the file. So remember, when you're using SMB client, you can actually do file name autocomplete with a tab. So that's very convenient. So we're going to get this file, download it, and there's nothing else in here, so we're just going to exit. So exit program, and we're going to see that log file is here. So to read it, just going to cat this file out and see over here. Okay, so we get some information. So permission denied, localhost, web, cannot find this path because it doesn't exist, and a couple of other error messages as well. But down here, see this command being used. Net use, localhost, web, user Marcos, and then some sort of password over here. So the password is inside the log file for this user Marcos. And we actually saw Marcos in the list over here. So this is probably a legitimate user, and we have their password now. Okay, so what can we do with this information? We can log in as Marcos now, or rather we can enumerate what kind of access they have. So Marcos, we're just going to copy this username, and we're going to run Netexec again. So Netexec, we're going to run the same command, but this time we're going to run it as Marcos, the super password, and we're going to find out what shares Marcos has access to. So we run that command, and we see that Marcos has different commands. So we were able to successfully access the Marcos account with the super password, and we see here that they have access to the logs directory, the logs file share rather, and they also have access to the web file share, and they have read and write permissions. So not only can they read and download files from this file share, they can also upload files to this file share. Okay, so what does that mean? Let's go over what kind of vulnerability this is. Here. Okay, so this is an SMB file upload into web server access vulnerability. So if we're able to access an SMB file share with write access to a web accessible directory, and we're assuming in this case that's the case, we could leverage these two conditions to gain remote command execution on the server. And because this is a Windows web server, it's likely able to execute code written in .asp or .aspx files. So we can prepare such a file for upload. So I've got one particular shell that I'm going to be using for this this Windows web server. At the link. So if anybody's wondering what the link is for the shell that we're going to be using, hey, and this actually has something to do with the file uploads attacks that we were talking about earlier. Let's access this here. Okay, so this is the this is the reverse shell that we're going to be using to access the target. And what we need to do is we're just going to copy this this code from the web page, and then we're going to go back, and we're going to create a file with nano called shell.aspx. So inside this shell.aspx, we're going to paste in all the code we got, GitHub repository over there, and we're going to change a couple of variables. So string host, we need to change this. We need to change this to our own host IP address. What was that again? I need to look that up. I think we should be using this one. Okay. Here, okay. So string host, we have to change out this IP address. And then for the port, I like to use port 443. Okay. So from here, we're going to save out the file because we've changed the two variables that we need to, which is the IP address and the port. We're going to Control X to save and exit. And from here, what we're going to do is we're going to access SMB as the Marcos user. So it's just going to be SMB client, and access the web file share as the Marcos user. It's going to ask us for the password. It is super password. And then from here, see that when we use SMB access, see the index.html file here. So if we wanted to be super sure that we had file upload access to this to the web accessible directory, could create something like a test file. Maybe we would do echo HackerFrogs like and subscribe, and we're going to output that to a file called test.txt. Okay, and we can try uploading this. So in our SMB client over here, we're going to put test.txt. And it says we were able to put test.txt file in here. We can try to access this from the web. So from the web, on the simple website, we're going to access the endpoint test.txt. And we get this, we were able to successfully upload this file, test.txt. It says HackerFrogs, like and subscribe. Okay. So now that we know that we have file upload capability, we're going to set up a reverse shell listener on another tab. So another tab here. So I've learned to use the rlwrap command along with netcat, especially when I'm doing Windows CTFs. So rlwrap is basically a little utility that gives your shells a little more functionality. When you use rlwrap with netcat with a Windows reverse shell, you're able to do command history, and you can also move around inside the CLI, which is a little bit more convenient when you're using a bare bones netcat shell. But anyways, it's going to be rlwrap netcat nlvp 443, and this is going to set up the netcat listener. So from there, listener is here and it's listening. We're going to upload the shell.aspx file with SMB client. I think I can clear. I can't clear. I can CLS. I can't CLS either. Okay, so we're just going to put shell.aspx, and that's going to upload the file. So we should be able to access shell.aspx from the web root, because this directory also has the index.html file. So we're just going to go over to web browser, and instead of test.txt, we're going to access shell.aspx. Okay. So when we execute this, when we navigate to this page, we're going to see that the web browser tab is hanging, which means we probably have code execution. So let's take a look at our reverse shell listener. So the reverse shell listener was able to pick up a shell, and we see here that we got a connection from target server, which is great. If we ask who am I, it says we are IIS app pool, default app pool. So this means that we have to do our bit where we play as Scary Hacker Voice Man. All right, Scary Hacker Voice Man, please come out.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out whenever we break into a server, and we've just broken in. you decided that it would be okay for your weak password users to be on the system, huh? With SMB access to web directories? Well, that was a big mistake. Maybe you knew about these vulnerabilities, or maybe you accepted the risk. Well, you accepted the risk. And now we're in.
All right, everybody. So now we're in, and we are the IIS app pool user. The IIS app pool user is usually the default user for web applications. So whenever you catch a reverse shell using some web application vulnerability, this is the user that you usually get the access to. So what can we do to elevate our privileges? So from here, what we want to do is we want to elevate our privileges until we have the privileges of the highest access user. That's usually going to be an administrator or the system authority user. So one of the first things we can do to figure out what privileges we have is we can give this command right here, whoami/priv. So after we do that, we're going to see that we have these different privileges on the system. So most of these are not super important privileges, but there's one very important privilege that we have here. And this is usually a privilege that is associated with the IIS users. And this is the SeImperonate privilege. So what is this privilege? So we're going to talk about what this privilege does. So what is this vulnerability here? What is this access, rather? So we're talking about privilege escalation. So SeImperonate privilege is a pretty common privilege escalation vector in Windows machines. And the SeImperonate privilege is a feature which allows a user to perform commands in the context of other users. So we can kind of think of the SeImperonate privilege as something like either the sudo command or SUID binaries. So this privilege is typically associated with service accounts like the IIS SQL Server and administrator accounts. And using SeImperonate, attackers can elevate privileges to system or administrator level either through token theft and or named pipes. So what are we talking about, token theft or named pipes? So it's a bit complicated to explain right now. All you need to know is that using the SeImperonate privilege, we can use the tokens of higher level users on the system, and we can also take advantage of input streams of other users or services. And this is how we elevate our privileges using the SeImperonate privilege. Okay, so we're going to talk about a very common family of exploits on Windows systems. And this is called the potato exploits. And the potato family of Windows exploits are all going to leverage the SeImperonate privilege in different ways to achieve elevated access on Windows targets. So there are a lot of these potato exploits, and the potato exploits, well, there are potato exploits out there called Juicy Potato and Rogue Potato and Rotten Potato and all sorts of different potatoes. And the difference between these different potato exploits is it's pretty subtle, but they mainly come down to Windows patching different vulnerabilities that take advantage of these potato exploits take advantage of, and then they have to create a new potato exploit to take advantage of the vulnerabilities in new Windows operating systems. Okay. So which potato exploit to use on a target largely depends on the version of Windows being used And in this case, we're going to be using the DeadPotato variant. So DeadPotato is a fairly modern version of the potato exploit, and let me get the GitHub repository of DeadPotato. There you go, and here you are. Okay, so we're going to go over to the GitHub repository with the potato exploit. Okay, this is the repository. We've got DeadPotato here. What I'm going to do is I'm going to go over and I'm going to get the binary, and that's going to be in the releases. I'm just going to click on releases, and let's see, DeadPotato net4.exe. Okay, I'm going to copy this link, and then I'm going to download it to my Kali Linux box. So Kali Linux, here I am. I'm going to wget that binary. Okay, so we've got the DeadPotato file here, and we're going to upload it using SMB. Because we have SMB access, we might as well use that access to upload this this exploit file. So here in the SMB client, I'm going to put DeadPotato net4.exe. Okay, so now the file is over here. All we need to do is we need to execute this. So we're going to go over to here where we have our access to the Windows box, and we need to go over to the web root of this particular web application. That's going to be in the inetpub directory over here. So we're going to cd into inetpub, and we're going to go into www root. This is going to be the root of the web application. Okay, and in here we see DeadPotato net4.exe. This is what we're going to use to get take advantage of the SeImperonate privilege that our current user has, which is the IIS app pool user. So DeadPotato can do a few different things, and in this case, what we're going to do with DeadPotato is that we're going to get it to run a reverse shell command. So because we're going to get it to run a reverse shell command, we need to set up another netcat listener. So over here in Kali Linux, we're just going to do rlwrap again, and we're going to use port 443. Remember that when the listener gets a connection on port 443, port 443 becomes available again to use. So you can use the same port over and over again, and that's not really an issue. So let's start up another netcat listener on 443, and then here I can clear. We're just going to use deadpotato.exe. So the command is going to be deadpotato.exe. Wait, it's not called deadpotato. It's called deadpotato net4.exe. And we're going to get it to run a reverse shell and call out to target 190 this one. And I think I'm 116, and we need to specify a port. In this case, it's 443. So in case anybody's wondering what this command looks like, it looks like this. Okay, so we're going to run the command, get our banner for DeadPotato, and we need to take a look at our reverse shell listener. So initiating procedure as NT authority. Is impersonation possible in current context? Yes. Currently running as user NT authority system. Elevated process started with PID 1940. Okay. So we go over to our reverse shell listener and we got a connection. So connect from here. If we ask who am I, it says we are NT authority system. Awesome. So we've rooted the box because we have the highest access. NT authority system is the highest level user on a Windows system, and we can do this redeem here.
What are you? I'm system root.
All right, so all we need to do now is we need to collect our flags. So on any of these CTF boxes, the goal of the exercise is to go into the administrator or the root user's directory and to read the flag files. So I'm just going to go into C users administrator. Can I not? Hold on. The authority system. Okay, I'm going to go into C users. And oh, it's not an administrator. This is a Spanish version of Windows. So the administrator is not an administrator, but an administrador. Okay, so we can move into the administrador directory, and then we can go into their desktop, and we've got the root.txt flag in here. So I'm not going to directly read the root.txt file because it's kind of impolite to read flags on live streams or videos. What we're going to do instead is we're going to read the .txt file and output it to a file called iread.txt. And we see here, because we were able to create this ireadroot.txt file, and it has the same file size as the root.txt file, we can effectively say that we did read the root.txt file and we've completed the exercise. All right, so that was a guided walkthrough for the simple challenge from the HackMyVM platform. And if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.